Hi, and welcome to the keynote session with Pooja K. Agarwal. Pooja is a cognitive scientist conducting research on how students learn since 2005. She's the author of the book Powerful Teaching: Unleash the Science of Learning and an assistant professor at the Berklee College of Music in Boston. Pooja is also the founder of retrievalpractice.org, a source of research-based teaching strategies for more than 15,000 teachers around the world. Today, Pooja will talk about the foundation of what the science of learning is in very practical, applicable terms. She will share specific examples of what you can do in your classroom to improve your students' learning. She'll also talk about study strategies, how students can use concepts like retrieval practice and apply them while studying so that they can use the science of learning at home to study smarter, not harder. You can ask questions using the live discussion box. And now it's time to listen and learn from Pooja.
Hi everyone, and welcome to EDUtech Asia. My name is Dr. Pooja Agarwal. I'm a cognitive scientist. I've been conducting research on how students learn for 15 years. I'm also a teacher. As a college professor, I teach psychology and neuroscience to about 100 college students in Boston, Massachusetts each semester. Today, I am so excited to be sharing with you Powerful Teaching: Unleash the Science of Learning. It is such an honor to be here with you to share the science of learning with educators around the globe. What we'll be doing today is focusing on three aspects from the science of learning. First, just a little bit of research that cognitive scientists have conducted for more than 100 years. Second, powerful teaching strategies that we can use in our classroom, specifically focusing on a strategy called retrieval practice. And third, powerful strategies for our students, what the science of learning means for them and their successful long-term learning. I want to mention that all of today's slides and resources are available at this website, retrievalpractice.org/edutech. There you can download the slides that I'm presenting today. You can subscribe for email updates, download the research, and access more free resources for your classroom. To get us started, I want us to think about our own learning and memory. For example, what is it that you would like to remember from this video? What would you like to remember by the end of today? What would you like to remember from your next professional development workshop? As we continue talking about learning for our students, I also want us to think about what the science of learning means for us. For us, our memory, our remembering as well. So we'll return to that question in a few minutes. To start, I also wanted to present a very basic model of learning. This is a three-step model from the 60s and 70s, again, very simplified. The first stage is what we call encoding. That stage of learning is when we're getting information into our heads, getting information into our students' heads, whether that's through lectures, textbook readings, watching videos. That's encoding, that first stage of learning. The second stage of learning is what we call storage. So we've encoded this information, and now we hope that information sticks. We hope it gets stored in our brain, in our memories. And then the third stage is what we call retrieval, digging around in that storage and retrieving, pulling that information out of our heads. What we do when it comes to learning is we typically think about that first stage of encoding. We often focus on getting information into our students' heads. What we know from more than 100 years of research in the science of learning is that we need to be focusing on getting information out of students' heads, that retrieval stage. We learn when we get information in through encoding, but a critical process and component of learning is also getting information out. Before I go on, I want to ask you this random trivia fact to think about how many bones are in the human body. So take a minute, you could pause this video, you could write your guess down, share it with a friend, tweet on social media. How many bones are in the adult human body? So I'll give you just a second to think about that. I want you to retrieve, maybe you're traveling back to elementary school and thinking about biology. How many bones are in the adult human body? The correct answer is 206. Each of us have about 206 bones in our body. So you just went through this retrieval stage, trying to pull that information out of your head. It's one of a key strategy we use in powerful teaching. There are other strategies called spacing, interleaving, and feedback-driven metacognition. Today, I'm going to focus on that first powerful teaching strategy, retrieval practice. Now, retrieval practice, again, is simply bringing information to mind, mentally traveling, putting in some mental effort to bring that information forward. And again, more than 100 years of research demonstrates that this active retrieval improves students' long-term learning. Not just the short term, what they're going to remember from our lesson today, but of course, we want to facilitate and improve students' long-term learning. So I'll be providing some examples of what this looks like for us in the classroom and what this looks like for our students, how we can engage in retrieval practice to really boost and unleash our long-term learning. To give you just some highlights of research that have been conducted on retrieval practice. Again, there's more than 100 years of research. I want to highlight two studies that I have published with my collaborators. So one is with my collaborators at Washington University in St. Louis, Missouri, where we took basic laboratory principles of retrieval practice and applied them in real classrooms. So for almost 10 years, conducted with grades 6 through 12 students, we engaged students in retrieval practice through the use of short quizzes. Students each had little remotes where we displayed questions at the front of the classroom. Students could click in their answers. So these kind of very brief mini quizzes. And over that 10 years of research, we showed that just these brief clicker quizzes improve students' grades from a C to an A level. We also examined whether or not retrieval practice improves students' higher order learning. Of course, it's understandable these constant quizzes in class sounds like it would only improve retrieval of basic facts, but we also found that retrieval practice improves higher order learning, complex application and transfer for elementary students and college students. Additional research has demonstrated that this act of pulling information out improves long-term learning for engineering students and also long-term learning, even neurology diagnoses for students in medical school. So a wide variety of topic areas, subject areas, and ages. Recently, my colleagues and I conducted a thorough review of the literature on retrieval practice, but specifically in classroom settings. So again, a lot of research has been done in laboratory settings or been done with educational materials, but we wanted to focus on all of the research that's been conducted on how retrieval practice works in the real classroom setting. So my colleagues and I looked at about 50 experiments, and here are some of the key recommendations we found. First, of these 50 experiments, the majority of effect sizes were medium or large. What that means is that retrieval practice consistently benefited student learning to a pretty large extent. These weren't small effects, but very robust and consistent. Interestingly, we found that only 3 out of 50 experiments were conducted in non-weird countries, which means only 3 experiments were conducted outside of the United States and the Netherlands. Weird stands for Western, educated, industrialized, rich, democratic countries. And those 3 experiments were conducted in Taiwan, Turkey, and Pakistan, which means we really need a lot more research on retrieval practice outside of Western settings. We also need more research on how retrieval practice influences learning when it's in the format of pop quizzes, non-science, non-medical content, and again, more diverse samples. Lastly, we found that a variety of conditions, all of the conditions of retrieval practice benefited student learning. We didn't find optimal timing. It didn't matter how much retrieval practice, when retrieval practice, the format of retrieval practice. In general, retrieval practice improves students' learning in classroom settings. That's it for the little bit of research I wanted to share with you. Let's move on to powerful teaching strategies. What does this research mean for us in the classroom? One thing I am so excited about with these strategies is that they don't require more preparation, and they don't require more grading. None of us want any of that. So what does this look like in the classroom? Just some examples from my own classroom. These are some of my college students in Boston, Massachusetts, and we engage in retrieval practice in every lesson, throughout the day, every week, every month, every semester. I provide students with little quick mini quizzes that are about 2% of their grade, and I'll give you some more information about those in a minute. I also have adapted all of these strategies with my college students on Zoom, for example. So these strategies are flexible, no prep, no grading. They work in person and online. Using the chat box in Zoom, for example, using Google Forms, a lot of tech apps work really well to embed and increase retrieval practice in the classroom. Here is one of the simplest strategies to think about. So often we might start class by saying, here's what we did in class last week. That's encoding. That's that first stage of learning, getting information in. Simply to switch it to retrieval is to just ask our students, what did we do in class last week? Giving students 30 seconds to mentally travel back, to use that effort, to pull that information out, to retrieve, that's going to boost their long-term learning. So a simple switch is just going from reviewing material to retrieving material. No prep, no grading. You don't have to collect what students write down, and you can just move on. To come back to that trivia fact question, how many bones are in the adult human body? I asked you just a few minutes ago, and the answer is 206. So there's another example. I could have just told you the answer at the outset, like how we review at the start of class, but I asked you to retrieve that information, which will help your learning as well. Some more strategies for the classroom. One is just called a brain dump, asking students to write down everything they can remember from a lesson, from the week, from the month, from a unit. In the scientific literature, we call this free recall. And we know that simply writing down everything a student can remember improves their long-term learning, their transfer of information, and the way they organize that information. Another strategy I call 2 things. This is just taking a brain dump and making it a bit more specific, where you ask students to retrieve 2 things. What are 2 things you remember about class from last week? What are 2 things you remember about any topic from your class? And this can be done at the end of the day, in the middle of a lesson, at the end of the week. Students can do this at home. It could be 3 things, 4 things, 5 things. I just like the simplicity of asking students to retrieve just 2 things from what they've learned so far. Another strategy that maybe you already use is called Think, Pair, Share. We might pose a question to our students. Think about how this topic relates to a previous topic. And then we might pair up students, and then students share with the whole class. So this is a pretty common technique, Think, Pair, Share. What I found is that so often we skip the think step. That's where retrieval happens. We need to make sure students are thinking and retrieving before they pair and share. So I encourage my students to write down for that think step before they can turn to their partner, before a breakout group. Make sure that you are not skipping the think part of Think, Pair, Share. Another strategy in general, as I mentioned, are mini quizzes. So in my class, students fill out a Google form. The quiz is worth less than 2% of their grade each week, so they're intentionally low stakes. This focuses on retrieval practice as a learning strategy, not an assessment strategy. This isn't a test, this isn't an exam, this isn't a midterm or a final. It's simply engaging students in practicing. So a few tips, if this is something you'd like to implement in your classroom, you could provide this as an entry or exit ticket at the beginning or end of class. Of course, again, tech tools and apps are very flexible. In general, whether retrieval is written or typed, that improves student learning. So use both or either. Multiple choice and short answer questions, research has demonstrated improves student learning. And again, in our review of the literature, we have not identified an optimal timing or spacing of retrieval practice. So I like to really focus on what works well for you and your students and your classroom. The more retrieval practice, the better. So do what works well for you, whether it's paper, pencil, typed, tech tools, multiple choice, short answer. Do what works for you to incorporate the most retrieval possible. To segue, I wanted to discuss how these strategies can apply for our students. How, based on the science of learning, students can remember more, which means they can actually study less. So often we have students who are cramming, who are nervous before a test or an exam. They might cram and then bomb the exam, or we've probably had this experience. Maybe students cram, they get an A on the exam, and then what happens? After they take the exam, they forget it all. And then we have to reteach and reteach, and students have to restudy and restudy. The reason this happens is captured by this quote that I really like. Learning that's easy is like writing in sand, here today and gone tomorrow. So that easy learning, that cramming, forcing, focusing on the encoding, that's easy learning. That's writing in sand, that's here for today. But then that easy learning washes away. It disappears. It's gone tomorrow. This is a quote written by my colleagues called Make It Stick that I highly recommend. I have more resources on my website. But again, they talk a lot about also this concept we call desirable difficulties. This mental effort of retrieval is challenging, it's difficult, and that's a good thing for learning. So when it comes for student study habits, many students already use flashcards, but they could use them in a more challenging, more efficient and effective way. So based on the science of learning, here are 3 tips for your students. First is to make sure that you're actually retrieving overtly, out loud, writing the answer down instead of covertly. So often students will use a flashcard and look at the flashcard and think, yeah, I know that, and then they flip it over and then they're done. That's wasting their own time. They need to make sure they're retrieving overtly. A second tip is for students to shuffle their flashcard deck. If they're learning their flashcards from the beginning to the end, the beginning to the end, they're just going to remember the beginning and the end. A powerful teaching strategy we use called interleaving shows that if students shuffle up their flashcards, that's a desirable difficulty, an added challenge, and students will remember more. So make sure students are shuffling their deck. They're not just going in the same order. And finally, make sure students are repeating this process. Again, students shouldn't be looking at a flashcard, thinking they know it, and dropping it out of their deck. Research demonstrates that students should keep their flashcards in their deck, ideally at least 3 times. Just because a student gets a flashcard correct does not mean they actually understand it. It could have just been a lucky guess. So encourage your students to keep their flashcards in their deck at least 3 times. If students follow these steps, they'll remember more, and so they can actually study less. If students are using flashcards, which is retrieval, but using them inefficiently, then they're just kind of wasting their own time. So those are 3 tips based on research for flashcards. One more strategy for students I want to encourage is what I call retrieve taking. It's a little spin on note taking, but in a more powerful, robust, beneficial method. So in this strategy, we can do this in our classroom. Our students can do this at home, where we can teach a lesson. Students can be reading a textbook, but to not take notes during that lesson or while they read. Then we should pause our lesson, or students can close the textbook and then retrieve their notes. Write down their notes during the pause from the book or the lesson, and then open the book or continue the lesson for feedback. So in other words, rather than trying to take notes simultaneously while students are reading or paying attention to a lecture, is to just pay attention, put the note taking away, then provide the opportunity for retrieval instead of being able to access notes at the same time. So it's focusing on retrieving notes rather than just note taking the way we always typically do, focusing on encoding. In this way, you're focusing on retrieval. So in general, whether it's applying the science of learning for teachers, for students, with retrieval practice, we know that you don't need to grade any of this. You don't need to prepare. It can just be a pause and asking students to write down 2 things. These strategies don't take long at all. I know we're all pressed for classroom time. Something as simple as a brain dump could take just 1 minute in class. Lots of research demonstrates that these strategies boost long-term learning, and the more we can save ourselves time, the more content we can teach, the more we can move on without getting stuck in this cycle of reviewing and revisiting our information. So to come back to that very first question, what is it that you want to remember? Take a minute. I hope you will do this overtly. Write down what is one thing you want to remember from this video. You can pause the video and write that down. I really encourage you to retrieve. Try this for yourself. What is one thing you want to remember from this video? And lastly, how many bones are in the adult human body? I hope at this point you've retrieved and know that it's 206. So if that's the one thing you remember from this video, I hope at least it's a helpful reminder about the importance of retrieval practice. Thank you so much for taking the time to watch. I hope you will visit my website, retrievalpractice.org, for more information. Check out my book, Powerful Teaching, and let's unleash this science of learning together. Thank you so much.
Thank you, Pooja, for sharing these incredible lessons. I hope educators are watching and inspired to try these practical strategies in your classroom immediately.